Hello, everyone. This is a Decision Options podcast. My name is Gill Eapen. My guest today is Aby Alexander, who's the CEO of Broadsat Technologies, that is on a mission to deliver cutting edge connectivity solutions where traditional fiber infrastructure is not viable. His expertise in ATSC 3.0 and broadcast internet technologies has been crucial in shaping the innovative approach to remote area connectivity. Prior to founding the company, Aby was the president and CEO of Thomson Broadcast Americas and Thomson Holding. Welcome, Aby.
Thank you, Gil. Thank you and pleasure to be here.
Yeah, thanks for doing this. So, we want to talk about your company, Broadsat Technologies. And I've been reading through some of the materials. And I want to start with sort of at the highest level, which is the problem worth solving. So, you say here globally, millions in remote areas lack reliable internet, creating a digital divide that hinders progress. This gap severely impacts healthcare access, educational opportunities, and economic growth. Disconnected communities face insurmountable barriers, perpetuating cycles of inequality. Yeah, so I'm familiar with this a little bit, Avi. So I spent some time on south side of Chicago.
Mhm.
So taking this closer to home, um, we have a similar thing going on in some parts of the major cities of the U.S. Which we don't really expect to see, but there is a digital divide between south side of Chicago and the north side of Chicago, which is just a few miles. And so you can imagine how bad this digital divide is if you think about the world as a scope. We got 8 billion people.
Correct.
Maybe two-thirds of them don't have access to broadband internet. And I'm a big believer in, if you build a population, an educated population with health,
Mhm.
um, that is the most important thing a country can do. So this is a problem clearly worth solving. So you want to talk a little bit about the problem itself?
Yes. Thank you, Gil. You framed the question very well because we had a webcast with one of the ex-FCC commissioners of US, and he was mentioning to us that in the US alone, we do not have approximately around 18 million people do not have broadband access.
Yeah.
And that was a very big number
Mm.
when you look at it. And when you go beyond the scope of US and go to South America and Caribbean, the amount is so vast.
Yeah.
Just bringing connectivity to the remote
Mm.
region, right? So that becomes a challenge, and majority of them are looking at fiber as an alternative or a fiber first kind of approach.
Mm.
But as you know, fiber to lay fiber, it's so expensive
Yeah.
and very difficult to maintain. And the technology itself can go obsolete with
Mm.
fiber, with new technologies coming on and switches upgrades and things like that. And it's a costly affair.
Mm.
Uh, in the US alone, there is a federal initiative called the BEAD program.
Yeah.
Uh, During that BEAD program, they have allocated around $42.8 billion,
Mm.
the B, uh, to bring connectivity to remote states and villages and towns which do not have connectivity.
Mm.
So that is allocated by the current administration, Biden's administration, and
Mm.
it was being talked upon before that. Now it is being implemented. Every state is literally looking at allocating that funding, and their priority is about fiber first is number
Yeah.
one,
Yeah.
and so that will take a longer time. So
Mm.
I was in the broadcast industry, and I saw this opportunity where the broadcast, as you know, it's one way. So With the ATSC 3 or the next gen TV standard, you have an IP backhaul connectivity.
Mm.
So when you look at connectivity to get an HTTP GET, to get a web page, it is an HTTP GET, and then it goes for a response backend.
Yeah.
So we could use that technology during that time and this standard and expand that standard to make that available for connectivity.
Mm.
So yes, go
No,
ahead.
no. So I was just thinking the raw numbers. So you said about 20 million people, approximately 20 million people in the US without broadband connectivity, um, which is, let's say, it's about 7 or 8% of the population.
Correct.
We of the 8 billion that we have in the world, probably 5.5 billion still don't have it. So that's about two-thirds of the world population. So it is a big problem. It's a big challenge. And as you say, if we are going to take status quo technologies like fiber and try that, very high capital costs and very high disruption in many ways because you got to lay this fiber all around the place to make
Right.
it happen. And then the half-life of that technology could be very short.
Yes.
And so there is a problem. Um, and so your solution, Broadsat, is really about ATSC 3.0 and TV white space, right? So talk a
Correct.
little bit about ATSC 3.0.
Yes.
I know there was a ATSC 1.0 standard some time ago, right? So this is sort of new thing coming through, isn't it?
That's right. Yes. ATSC 1.0 was around 20 years ago. That
Okay.
was the digital conversion that happened. Most of the Americans and also outside US have adopted some of the ATSC 1.0 standard. And now there is a new, it took us around 20 years to get to
Mm,
ATSC 3.0,
yeah.
while you have internet was not even an option at that time. 20
Mm,
years ago, it was just coming up. And now integrating that with streaming,
mm,
and the broadcasters were losing the edge of getting connectivity to their home. And you have cord cutters who are cutting the cord, and
yeah.
also how are they consuming video? It was all through on demand.
Yeah.
So ATSC 3.0 came in, and it's around 80% of the US broadcast market
Mm,
today.
mm,
And ATSC, there were a couple of uh, key markers that happened during ATSC 3.0. Prior to ATSC 3.0, there was something in the broadcast industry called repack.
okay.
So repack was a reverse auction for the band, what do you call it, the spectrum
Yeah.
allocation.
Yeah.
And the spectrum was reverse allocated, reverse auction to one of the biggest MNOs, mobile network carriers like
Mm,
T-Mobile, AT&T, and all that. They bought the spectrum. And some of those uh, broadcasters, especially on the high power side, they were sitting on that spectrum. They had to be reallocated a
mm,
new channel number. So that happened, and that was a huge market, and FCC paid for all the upgrades.
mm,
So automatically, the broadcasters had a good way to have a new standards being adopted,
yeah.
and they switched over. Some of them, 80% of the market has switched over to ADSC 3.0.
Mm,
And internationally, Jamaica, now Trinidad, Brazil has adopted this kind of standards, incorporating their standards into
mm,
ATSC 3.
mm,
And also India is also looking into this standard. Trinidad and Tobago, they also announced it recently. So this standard has been growing
yeah.
very well. So one of the advantages of the standard is that it can have a backhaul or internet connectivity to connect. If
Yeah.
you're watching a video, there can be a response or an HTML file that shows up, and you
Mm.
can interact with that. That's a game changer for broadcasters. Right?
It's a game changer. So I was thinking, Abby, I think the U.S. Well, let me make a statement, and
Yeah,
you can react to it. In the telecommunication area, sometimes the U.S. has been lagging, um, yeah, and it sounds like in ATSC 3.0 we are really leading because not many parts of the world have gotten onto it, right?
that's right. Yes, especially in the broadcast side, we are pioneers in that.
Yeah.
Uh, and Europe is taking some of the standards. There's another standard called DVB-T2. And when I was with Thomson, we were one of the founding members of the DVB-T2 standard.
Mm.
But they don't have an IP backhaul yet, or they have a DVB-T2X standard that they are talking about, but it's not ready yet.
So let me understand the ATSC 3.0 a little bit better. So if I understand this correctly, this is telecommunications through antennas. So there is a TV station that can beam stuff in a customized way to an antenna, and the antenna can pick up whether it's a streaming service or internet or whatever the case may be. Is that how it works?
Right. It's not a streaming service, it's a broadcast service.
It's a broadcast service.
So
Okay.
it's a traditional broadcast. So
Yeah.
they would go ATSC 3 from the antenna. So if you have an antenna, a receiving receiver, what they call the ATSC 3.0 receiver, you
Yep.
need a specialized receiver for that. And once you have an antenna, you can get 4K, up to 4K video and
Mm.
Adobe Atmos audio system. So it's a best of best quality of video and
Mm.
audio together. And also it has different markers or text that you can send out, or markers that you can pop up, um, like ads and all those kind of things, and interactive ones.
It can be customized. Yes, when I was growing up in India, Abby, we had the regular TV, and I had to go up on the roof, sometimes to turn the thing, one way or the other to get the right reception. Is this antenna like that? I mean, it has to be on the roof or something, or is it a
It
different thing?
doesn't not need to be on the roof. It can be a wall-mounted antenna or a window stick-on antenna, depending upon your coverage. When you tune that stations, you automatically get those stations, and
Okay.
pretty good quality. And with ATSC 3, the broadcast does not have to use that much, because the pipe itself, it has multiple PLPs, what you call multiple singular pipes, that
Yep.
you can put a lot of stuff into that, and the quality is much more compressed and much more easier to receive.
So when you say 80% of the US has this capability, 80% of the TV stations in the
80% of the
US could do
broadcast,
ATSC 3.0?
yes.
Yeah.
70 to 80% is what I saw the
70,
number.
80%.
Yeah,
So at
yeah.
least approximately three-quarters of the. So I don't have ATSC 3.0, but what percent of the population, general public, has
Mhm.
adopted ATSC 3.0?
So the biggest bottleneck, Gil, is that the receivers are very expensive today,
Yeah.
right? So unless there is a FCC mandate or
Yeah.
some kind of push for the receivers to be subsidized,
Mm.
people are not receiving, they're not buying the receivers unless and until they want to watch the Super Bowl in a high definition, or a HDR or 4K kind of a resolution. But
Yeah.
a lot of broadcasters are just getting into this.
Mm.
And the holy grail in this is not just on broadcast or the video alone, but also something called data casting. So
Yeah.
you can use this standard to send out movie updates, or streaming content, or in
Or internet even, right? Or
internet
yeah.
even. Correct, yeah. And so FCC, there was a rule making before, Ajit Pai had left FCC as a chairman.
Mhm.
It is called the broadcast internet. And some people call it broadcast. I mean, he coined the term broadcast internet, which I
Mhm.
love. Some people call it data casting. Some people call
Yeah.
it something else. But I think the broadcast internet is very crucial for this because it is giving broadcast signals and also bringing internet over to the third party over the air, right?
Mm. So what's the monetization model for the broadcasters? How do they make money with it?
So multiple ways. So today, if you look at the broadcasters today, they are more focused on ad revenues, and that's it, and or their content, they license it from somebody, and then they do the ad revenues on top of that. So with ATSC 3, you can create ad revenues. On top of the ad revenues, you can also demograph, like, for example, DMAs.
Mm.
Each of the DMAs, I can target an ad to a DMA1 and a DMA2. And let's give you an example. If a wealthy DMA,
Yeah.
uh, I can target an ad for a Range Rover or a BMW,
Mm.
versus a not so wealthy DMA, I can target uh, a Kia or a Prius or something like
Yeah.
that. So
Yeah.
once the targeted ads have been, dispersed, I can also send a small bug or a HTML shows up,
Mm.
and I can interact with it and say, um, have a test drive. So my information is already part of that set-top box and the
Mm.
IP. It
Okay.
cannot, if I give them the permission to accept it, the broadcasters knows that I interacted with the ad, and
Uh,
also the broadcasters can send a targeted message
yeah.
and an email notification back
Yeah.
from the dealer saying that Abby has scheduled a test drive.
Mm.
So
So it's a feedback. That's a
it's a
feedback
feedback.
mechanism built into
Exactly.
it.
Yeah. Yeah. So that's
So
very powerful. Now I can
yeah.
charge, instead of charging, let's say, Super Bowl, a 30-second ad will cost you what I've seen the numbers like 5 million or $7 million. Now
Yeah.
I do a targeted ad for $10 million, the
Yeah.
same. So that's very powerful for broadcasters, right?
Okay.
And
Yeah. So that monetization model could be much more variable than the status
right,
quo, potentially.
exactly, exactly.
And
And
so I'm not surprised the broadcasters are jumping on the bandwagon. But as you say, the problem is on the receiver side, it is still quite expensive,
yes,
and so customer adoption of the technology has been slow, right? Is it?
correct. Yeah.
Yeah.
The adoption has been slow, unless I think the new chairman takes the initiative uh, to make the set-top boxes cheaper or the
Mm.
receiver cheaper. I was at CES last week. There was quite a few TV sets that announced that they have the ATSC chip already embedded in it,
Built into it. Built
built
into
into
it.
it.
Yeah.
So that adoption will help to bring in, instead of a set-top box. So there are a couple of ways that I think adopting the technology is number one, and
Mm.
it's like building the roads and there is no cars, right?
Yes. Yes.
So we need some of them.
Yeah, excellent. So you have listed some target markets. We talked about it. So remote regions lacking fiber infrastructure worldwide that
Yes,
we established probably 5.5 billion people around the
yes,
world, approximately. U.S. rural areas, tribal lands, BEAD program targets maybe 20 to 25 million people in the U.S. Africa, Asia, emerging markets without broadband is pretty big, especially in Africa. Underserved communities in challenging terrains. Yeah, so south side of Chicago is close to my heart on that.
yes.
And then global last mile connectivity markets. So global last mile connectivity markets. So talk a little bit about that. So what do you mean by last mile connectivity?
So if you look at majority of the countries, I'll give you a story that hit my heart very closely. It's that we were in Jamaica, uh, um, set up the second broadcast tower with ATSC 3.
Yeah.
And I got to know the Minister of Telecommunication very well, Minister Morgan. And he spoke at the event and he was telling us about a story that when he had gone to a constituent, every Thursday he goes and visit them.
Mm.
So during that time, um, one of the visits, he saw an antenna sticking out of a tin roof, a
Mm.
small little thatched hut. And he was very inquisitive of what is going on. So he crawled into that. He went in and saw a little kid, a young kid,
Yeah.
trying to do trading online. You
Mm.
know, so he had come from the city, and he was doing the trading. So he was
Yeah.
so excited about this because he said, that is what I call digitization,
Yeah.
right? So most of the countries, if you look at it around the world, especially in Africa or Caribbean, like Dominican Republic, you have Brazil is an example in South America and other countries, all
Yeah.
across, they have the connectivity problem like we
Mm.
have in the US, and theirs is worse, you know.
Yeah.
So the terrain is so bad, so it cannot reach connectivity unless you lay the fiber. And the
Mm.
local ISPs has no interest to light up 200 or 500 households
Mm.
in that region. So
Mm.
now that is called the last mile, right? The
Okay.
last mile for these guys.
Yeah.
So how can we connect them? We have to look at some kind of a blended solution that would do a fiber and a fixed wireless, and
Yeah.
also integrating that with some kind of a broadcast standards or TV white space.
Yeah.
And TV white space is using this lower unregistered spectrum,
Okay.
and that is registered with the database. And we can send internet traffic all through, all um up and down. And with our technology, we can give around 100 megabits per second,
Mm.
uh, all the way as good as broadcast or broadband requirement. So they can get that connectivity to the last mile instead of connecting through fiber.
Yeah. So I want to understand the TV white space um, aspect of this. So we reserve some bandwidth for
Yes.
television,
Mhm.
and the TVs are not using it. So that bandwidth is sort of open, so to speak. So we can now use that bandwidth to push data through it.
Yeah.
That's idea.
Yeah. So it's more like a glorified Wi-Fi,
Yeah.
specifically using the TV spectrum, a lower bandwidth and lower spectrum on TV bandwidth or a TV spectrum. So that is, and you don't need to have a big license to be paid. You can go in and pay a nominal fee and you get that access.
So I mean, this seems like a an easy way to get into it. Why
Yeah.
aren't people doing it?
So
Why?
there were
Why?
a lot of big companies did that, like
Yeah.
Microsoft was part of the whole TV white space spectrum, and the
Yeah.
technology was a little bit behind. Now, more and more companies are getting into it, or they're making it better. The bottleneck was that they didn't have the right processing chip available during that
Okay.
time. Now there are good chips available, and also integrating TV white space, base station with uh, edge caching or edge AI,
Yeah.
uh, that will give us a lot more um, intelligent network or a next generation of intelligent network to do content delivery much
Hmm.
quicker. So the innovation is ripe at this time. Yes.
Yeah, so you have invested a lot into this, Abby, and you are sort of the leader in this. So, who would you consider your competitors would be or could be?
So there are a couple of not direct competitors, I would say. There are some competitions, like, for example, the moment they say, oh, I don't have internet, I cannot get fiber to that location. How about Starlink, right? So
Starlink, yeah,
Starlink is a good competition that we have. And Starlink is again using satellite,
yeah. I would
LEO.
imagine it's expensive.
It is expensive,
Yeah.
and also the reliability itself is also a challenge some
Mm.
places. And as in the US market, because US is, if you look at the curvature of the US, the globe, you need multiple of these LEO satellites uh, to to be
To cover
focused
it.
on that, covered in that area. While Africa is a little more flatter, so it's much quicker
Ah,
and less
okay.
satellites needed. So, so Starlink is definitely one of the competitions, but Starlink gives only connectivity. We bring in applications around it, like medical applications called, we have a product called
Yeah.
Medicon Connect, that enables your doctor to connect with your patients in the remote
Mm.
regions. Um, we bring in remote learning, part of that.
Yeah.
We bring
Yeah.
in emergency alert systems. So you have seen a lot of fires going on in California and
Mm.
earthquakes and things like that. So this broadcast towers are the last ones to, go down,
Mm.
because the cellular towers and all that gets hit very quickly.
Mm.
So the broadcast towers, so we are built on the broadcast infrastructure. So so to give an emergency alert quickly, we can do that very easily
Mm.
with the emergency alert system. So there are a lot of advantages that comes in with the package by itself. So it's very fascinating how we can
Mhm.
blend multiple technologies together.
Yeah, so as you say, it's not just the connectivity; it's the applications working on the platform.
Yes.
So healthcare, education, emergency alerts, as you say, and so sort of bringing all of those things together. I mean, that's what the utility is. It's
Yes.
not necessarily just the connectivity, but what do people do with the connectivity is a real question.
Right.
And I don't know much about this, Abby, but I know that Starlink is getting into some issues with Brazil and other countries because of all the political stuff that's going on as well. And so, I mean, beyond that, it is really the real question is how do you use it and
Yes.
what's the utility of the platform, right? So this is where you could bring in telehealth, healthcare more generally,
Yes.
um, education, just a big deal, and then emergency alerts and security more broadly, right? So that's the differentiation, I think.
Right. And and also we are testing right now. Another concept is how can we bypass or augment the CDN, or content delivery network, right? So if we have a base station or an antenna that would broadcast, and we create like a small mesh of networks together,
Yeah.
and from that mesh of networks, we can we know with Edge AI, we can look at all the content, all the content that is already going to get accessed by that group of users,
Mm.
right? And from that, we can deliver content very quickly into
Mm.
that edge caching device, and then just like a peer-to-peer network, enable that much quicker, right? So I give you an example.
Yeah.
So let's say Netflix today. Netflix, when they came up with the Squid Games,
Mm.
uh, and their subscription rate went up like crazy. Their new subscribers went up, right? Uh, then, as soon as the subscriber went up, the technology cost of delivery went up. Right?
Mm.
Then, along with that, their stock also had a fluctuation that took
Yeah,
place,
yeah.
right?
They had some
Because
pricing changes and stuff, right?
that's right. And
Yeah.
it had a lot of fluctuation that takes place just on one content, right?
Mm.
Now, they were paying a whole boatload of money to the CDNs of the world,
Mm.
right? So if you look at the OTT market, if you talk to the CEO of Disney or any one of the OTT market, Hulu or any one of them, they all say that their technology delivery cost is so high.
Mm.
So if we blend that with the data casting or what we call the broadcast internet,
Yeah.
integrate that in with ATSC3 and deliver the caching content into that small edge caching device. And I
Mm.
have a backhaul with IP, and it needs to fetch it at a time that it's required,
Mm.
right? And the cost per delivery for that particular file is much cheaper.
Mm.
Versus now, the CDNs can literally make some money out of it, right?
Yeah.
By and the second thing is Amazon is trying out, Netflix is trying out to do live broadcast, right?
I see. Yeah.
And so we are also doing some of this. There is a new broadcasting standards or a new broadcasting technology called the 5G broadcast.
Mm.
And that is using the 5G technologies to do multicast enabled network.
Mm.
So that means that you just broadcast from the tower, whoever has the cellular phone with that capability of receiving, they can receive live, beautiful live video on
Mm.
their cell phone. So that is being tested here in Boston as well with another company,
Mm.
and they're doing in making an inroads a lot in the broadcast side. In Europe, they use this to test it for the Olympics, uh,
Yeah.
last Olympics. So now there'll be two ways to deliver this content. If you're at home watching live uh, in a big screen, you need
Mm.
something like an ATSC3 to watch that. But if you are on the road, you're on your cellular phone, you don't need the ATSC3 to receive it.
Mm.
You can do 5G broadcast, and the
Mm.
technology standards get involved, right?
Yeah, so I want to talk a little bit about the developing world, Abby. So I know that you are putting a lot of effort in Africa, for instance, Chad and other countries. And so what are you trying to accomplish in those arenas? I mean, we know that there is a lot of need, and sometimes it's very challenging to go into those countries and transform them. What are the strategies you've been following there in Chad, for instance?
So we've been fortunate enough at the United Nations to meet with the Prime Minister as well as the Minister of Telecommunication and Digitization to sign an MOU with Chad, Republic of Chad. One of the biggest things that they wanted to bring in was telemedicine into
Yeah.
Chad and also connectivity to bring in smart cities into certain regions of Chad. So how can we bring Chad to be a much secure country, bring in more investments into the country, and look at their telecom infrastructure itself,
Mm.
and how can we make it and upgrade that into the next generation so that it's robust and the communications become better. So we are taking that path forward with them. And so we look at different cities or
Yeah.
states, one of the states that we've identified that we will light up that area and then move to the another state, to the another state. So that way we can get communication and also bring in some of the smart city capabilities into that country.
Mm.
Our underlying thing is connectivity, right? if the country is going digitization,
Mm.
a lot of African countries talk about digitization, but that gets focused only in the cities where there is connectivity. But
Yeah.
what you go away from the city, like you said, south side of Chicago, right? In the US. So, which connectivity becomes a challenge,
Yeah.
then the whole effort of digitization becomes a challenge as well. Questionable, right? So
Yeah. So,
that's
so I
what we
was,
are bringing connectivity over the airwaves.
yeah. So I don't quite understand this, Abby. So the underlying internet infrastructure, the backbone, that is still. So I know that there is internet cables going to India and places like that. So how would the internet traffic go? So think about a place like Chad. How will it be connected to the global backbone internet?
So the global backbone is already connected today because if
Okay.
otherwise they would not be connected to the internet. So each of those countries have something called interconnect.
Okay.
These are big hubs. Like for example, we have one in New York City and one in Miami that connects. These are massive fibers
Mm.
that goes under the ocean to
Yeah.
connect between multiple countries at the same time. So they are called the interconnect. So even in Africa, there are interconnects that comes in. The cable is already there. The main fiber network is already being laid out
Yeah.
already. So think about a highway system. So the main highways are laid out,
Already built. The main
already built.
highways are built. Yeah.
Exactly. And those are toll roads today, where everyone who comes in and connects into the highway, that connectivity, if you take the first exit and your home is right next to it, and that has a premium higher price, right? Versus down the line. So we are in the scenic route, what do you say, where we are connecting that scenic route part of it. So that connectivity is what
And
we
that's
are doing.
what's lacking, because
Yeah,
without that connectivity, you cannot get to the highway. Uh,
that's
and
right.
that's the problem, right? Yeah.
That's right. Yeah.
So, yeah, I mean, you're solving a big problem, Abby. So, you have some collaborators that you're working with.
Yes.
You want to talk a little bit about them? I mean, it is. I mean, no single company can solve this massive problem. So you probably need collaborators to help you do this, right? So talk a bit about your collaborators and how you're thinking about it.
So you're right. I mean, one small company like us, we cannot solve the digitization problem. So we partnered with really good companies that are one, I would highly say that it's Gorilla Technologies. They are based out of London. They're a NASDAQ publicly traded company, a phenomenal team that I work with, starting from the chairman, Jay Chandan, to all of the team. Um, they have, when we initially started the conversation with them, uh, one of the things one that got to my attention was that when I asked them, "Who are your reference customers?"
Mm.
and they said, "We don't have a reference customers, we have a reference country."
Okay.
So, which was very true, and they are when you go to Taipei and straight from the airport all the way to the Taipei city, or if you get a ticket in Taipei, is probably their cameras or their intelligent transportation system
Mm.
or their smart cities. They're doing one project in Egypt. They're doing another one in all over the country, all over the world, in fact.
Yeah.
So that is a very good partner to have. And when we needed something on the manufacturing side, they also control the supply chain.
Yeah.
So they had manufacturers who would manufacture, who are part of their ecosystem, And so we could get better pricing for delivery,
Mm.
uh, better technology. In fact, we were looking at building something like a CPE kind of a model, which we are collaborating with them because they have the skill sets to do it and much quicker. So partners like that helps us to scale much quicker and
Yeah.
faster than looking at somebody who will be like, okay, let's let's make a quick buck and move on.
Yeah,
And
it's very
that's right.
complementary, isn't it? I mean, they are going to generate a lot of data,
That's right.
and the backside of the data is communications, and so it appears very, very complementary.
Correct.
Um, and then you have other collaborators, big
Yeah.
companies like
So
T-Mobile.
we have a very good collaborator that we are working with. We are looking at Puerto Rico as a test bed. So Puerto Rico, we are looking at having a couple of towers with ATSC 3, integrating that with also 5G broadcast. And we partnered very closely with another company, more on the innovation side that they are doing called Engine 4 in uh, in uh, in Puerto Rico, in just outside San Juan, and they are working together with T-Mobile to bring in the next generation of connectivity. And so we are also with that access, we also got access into T-Mobile, and we are also working with them closely to build a solution that can be bringing connectivity to the region. So T-Mobile is another one that we work with. There are a couple of other smaller companies as well that we are partnering with. Very innovative solution. We
Mm.
are looking at how can we connect, quicker, faster, and easier, and and the quality of service. So we are partnering with quite a few other companies that we can't name yet. We have
Mhm.
some OUs in process with them that would help us to innovate better and bring solutions better.
So I know that there are multiple projects in play. Are you thinking about raising any money for the
Yeah,
company?
so we are in the process of raising some capital now, purely as working capital, and we have some projects in hand. So that's our biggest goal, just to make sure that we are not, shoestringing this on the, and also put some good efforts toward the innovation side, because we need uh, some good funding for convergence of these technologies. So if we bring in convergence to the technologies, that helps us to build it faster and better.
And then you're investing. I mean, you have already invested into a lot of hardware technologies,
Yes.
but you're also investing into R&D. So you want to
Yeah.
continue to improve the technologies going forward. We know the need is there. We
Yes.
know how you might be able to solve it, but we have to keep moving from
Yeah.
an R&D perspective, right? Yeah.
Exactly. And we have some very, very high-end engineers with us, and who has done some amazing work in the radio frequency side as well as in the telecom side. So they are my pillars, So I throw a challenge at them and they run, much faster. So I think that is more important. We have an amazing team that are part of our group. I think that is what helps us to build the innovations faster.
Excellent. You know, it sounds like a very exciting company, Abby, and hope you can succeed in this because clearly there's a worldwide need. We have to lift up people who have been left behind,
That's
so
right.
to speak. If you're not connected, it's really difficult to go forward from an education perspective, from a health perspective, from other perspectives. And so from a macroeconomic perspective, the real problem is how do you get all these people
Mhm.
equally connected
Right.
so that we can derive that energy into a macro scale. And that problem hasn't been solved.
Yes.
And I don't know if a lot of companies have focused on it, but you have appear to be definitely focused on it. So yeah, I wish you good luck with it.
Thank you. My concept is a lot of people talk about digital divide and how can we solve that big need, and digitization and all that. That is the mantra or the big talk
Yeah.
around people. So if we can move that needle a little bit and make somebody's life better, or a small kid who is sitting in the slums of Mumbai,
Mm.
or they may probably have better connectivity than
Yeah.
somebody in the remote regions. So, how can we bring that connectivity, them education, not only connectivity, bring them education, bring them content, bring them something that they can look up to and learn from that. And if there is one story that comes in, best, I think we had made a good impact over there, right? So I think that's our mission.
Yeah, absolutely. I just want to touch on one topic that I hadn't thought about. So, pharmaceutical companies. You were at CES recently, and pharmaceutical R&D is getting more and more difficult in many ways. But the problem to solve there is in the healthcare context is home healthcare.
Yes,
How do you get to the patient at the right time with the right intervention? For
mhm,
that, you need a lot of connectivity. You need sort of real time connectivity. You need home monitoring and all sorts of things. So it's all data related things. And so I think there's a huge market there too, where you
yes,
could collaborate with life sciences companies potentially.
yes, absolutely. So that's a big point. I mean, I saw that we have an initiative for telehealth right now, and we are coming out with this Medicon kind of a box, which is a CPE that
Yeah.
connects in. And we are looking that Medicon box as more of a hub for a patient that is at home. Home healthcare is a big, huge market. At CES, I saw that like pharmaceutical companies and medical device companies like Abbott had a big
Mm,
booth.
mm,
And there are these apps that are geared towards it. I tested in one of them that you don't need to prick your finger to look
mm.
at blood glucose level.
Yeah,
Fascinating.
it's an amazing,
Yeah,
amazing thing. Yeah.
amazing.
Yeah.
There was another company that was delivering injections without
Mm.
a needle.
Yeah.
So, you know, 5 years or 10 years ago, it was impossible. There was another company that had a mobile X-ray unit as big as
Oh, yeah.
probably like two iPhones. So you could carry that with you and do a quick X-ray.
Mm.
Uh, so I think there is a lot of innovation that is happening in this space,
Yeah.
and connectivity becomes a crucial part of it, as you said.
Yeah.
More and more people are getting older, want to stay at home. They don't want to disrupt that. Or somebody who had a heart surgery coming back home. They're pushed away from the hospital bed and they're coming back home. Their
Mm.
recovery or the post op is very important.
Yeah.
How can we get the data and have the doctors talk to the patient very
Mm.
quickly so that our healthcare cost becomes lower
Mm.
and cost of managing a patient becomes lower as well. So there's a lot of opportunities in this space, and we are just scratching the surface at this
Mm.
point. No?
Excellent, Avi. Yeah, I love what you're doing,
Thank
and keep doing it.
yes,
So
thank you
yeah,
so much.
yeah. Thanks for coming on the show.
Thank you for having me, and I'm so excited to be part of this. Thank you, Gil.
Thank you.